Hey, AP Psych students, can you guys hear me okay tonight? Excellent. Thanks, Rosemary. So our topic tonight is going to be statistics. And last time we talked a little bit about various research methods in psychology, and so kind of the other complementary half of that is the statistic portion, how we kind of measure our results. But before we get started, just in case you're new here again, I want to point out some things that you can do while you're listening to me. At the bottom of your screen, there are some different things that you can do. It says ask a question. If you click on that, while I'm talking, it'll just give me a little notification that you typed in a question, and I will answer that at some point when I have a little break in the talking and what I'm explaining. Occasionally, I might also post some questions in the poll section, so you can interact that way as well. And then there's also obviously the chat on the right-hand side of the screen there, so you can respond to me there as well. So before we jump in, just kind of letting you know what's coming up. We have next week, we start the bio unit, and the bio unit is huge for AP Psych. It's a lot of different information. It's one that kids sometimes struggle with quite a bit. And so we're going to spend 2 weeks going over different things with bio and neurotransmitters and the brain and genetics. Ooh, you have a bio test tomorrow. Well, Rosemary, if you have any questions at the end and you want to put them in the chat, I'll stick around for a few minutes just in the chat and answer them. Otherwise, you could also go to the Facebook page. I'm not sure if you're a member there, but on the Facebook page, if you have any questions later, I'll get on there as well and answer anything that you might have a question about. So after we do the bio units, then on October 9th, we'll be doing sleep and drugs, which is different states of consciousness. So here we go. Just a reminder, I like to do this every time so we see what unit we're in. We are in the research methods unit. And basically this idea is that psychology is a science. They keep reinforcing that because I think sometimes that's lost in the translation about psychology. This unit is 8 to 10% of the AP exam, so also a pretty heavy hitter. And the two main parts, we already talked about the specific methodologies. Last time we talked about case studies, surveys, experiments, and then now today we'll talk about the measuring of the outcomes of our research. So the first thing is just kind of identifying the types of statistics we're talking about in psychology. And so this little graphic here I find really useful to help kind of organize my my thinking. And so there's descriptive statistics and inferential statistics. And descriptive is, I think, fairly self-explanatory. They describe data in a meaningful way. And we can do that in kind of two strands, either using central tendency or variation. And we'll talk about all of those in a little bit more detail. But I would recommend maybe snapping a picture of this this chart to kind of put in your notes, because I think it's really useful when we start talking about the statistics, having a way to visualize and kind of plan them out in our heads. And then the other type of statistics that we're talking about in AP Psych are called inferential statistics. And when we are using the inferential reasoning method, we're basically like looking at that information and deciding if we can apply it to the population as a whole. So I'm trying to make an inference about my data at hand, about whether or not I can say that that is true for all AP psychology students or all women or all United States citizens. Can I infer what that information is telling me to the population in a broader context? So I'm going to go through, just as a preview, measures of central tendency next. Then we'll go into measures of variation, and then we'll end with statistical significance. For measures of central tendency, I tend to think we don't need to talk a whole lot about it, because this is kind of your basic math, statistical things that you've probably learned over and over already, maybe even starting in like middle school with some of the arithmetic averages and things like that. So we're going to talk about it briefly, but I'm not going to spend a ton of time on it. You have to know that the mean is the average of the numbers. And so you just add all of the numbers together. There's a data set there. 3 plus 5 plus 5 plus 6 plus 8 plus 10 plus 12. That equals 49. And so then to get the average there, we just divide by the number of data points we have, which is 7. So 49 divided by 7 is 7. So pretty simple stuff. I'm sure you all know how to do that, but that's just a refresher in case you forgot. The median then is just the middle number in the sequence. So if we're using that same data set there, the 3, the 5, the 5, the 6, the 8, the 10, and the 12, we just have to count and figure out what the middle represented number is. So if there's 7 numbers there, that means the 4th number is the middle, and so that would be 6. Mode, on the other hand, sometimes is tricky because it could have one mode in a data set, but the mode is just the most commonly occurring of the numbers. And so if we look at that data set again, there's 2 5s, so that means 5 is our mode. So basic kind of math stuff. I'm not going to spend a ton of time here, but what you do have to understand is why or when we would choose to use one of those statistics versus the other. That's kind of the tricky part here when we're talking about statistics. So how do I decide whether I want to use the median, the mode, or the mean in talking about or summarizing my data in psychology? So which measure of central tendency is best? And it really kind of depends what you're doing. You have to think critically here about the information. I think most commonly when we see a study referenced or even like a commercial on TV, they'll talk about the average this or the mean of this. And so that's probably the most commonly used descriptor for statistics, but it can sometimes be really deceptive. Looking at this image that I have here, each of those little green people represents a family. And so if I asked, let's say that this is my AP Psychology class, and I asked all of the kids what their annual family income was. See that a couple families make $15,000 a year, a good amount of families make $20,000, and then we have one family way up on the right side that's making $710,000 a year. If I took all of those numbers, added them all up, 15 plus 15 plus 20 plus 20 plus all the 25s, all the 30s, and I actually calculated the average, the mean is actually about $70,000. But if I look at this data and I have all my data points plotted, 70,000 isn't really an accurate description of the average income of my students' families, right? Because only 3 families are making more than $70,000 in my AP Psychology class. The rest, the vast majority, are making a lot less than that. So the problem with using the mean is that it can really be skewed by outliers, and you have to know that. You have to understand that. So when you see a study referenced or you see a commercial on TV talking about the average or talking about the mean and it doesn't seem quite right, think about how just one person over here, this $710,000 person, is skewing everybody's data upwards, and it's not giving us an accurate depiction of what the actual mean or the actual average is. So if we're concerned with the mean being skewed, we would instead look to using something like the median because it mitigates the outlying data. The median, which is 30,000, you can see represented in that image, is a much better example of what our average class income is. The mode would for this one be 20,000. Typically, I mean, you don't see the mode being used a whole lot. You still need to know what it is, but it's usually the mean or the median are going to be the 2 most common forms of describing and summarizing the data that we have at hand. So file that into your brain. You have to know the mean can be skewed, and so sometimes we want to use the median instead when we have really far outlying data. All right. So that's it for really measures of central tendency. I feel like you guys kind of know that stuff. And so we're going to talk a little bit then about measuring the variation in our data. So I have a data set here with just some numbers listed. The first thing that we can use to measure the variation in a data set is the range. And so the range is really just a crude measure. I take the highest number. So in this data set, the highest number is 77 and the lowest score, which is 62. And I just subtract 77 minus 62. So the range of my data is 15. That doesn't really tell me a whole lot because there could be a lot more numbers in between there, or there could be very few numbers in between there. So the range is a crude measure. We could use it, but there's other methods that give us much better description, because again, we're using descriptive statistics, so we want to describe our data and really understand it. So there's better measures of descriptive statistics. And so we're getting into something kind of complicated, and I want, before you even start freaking out about all of what it says under variance, you do not need to know the full out calculation for variance. I just listed it there so that you understand how that number comes about, but they will never ask you on an AP test to calculate it out. So you don't have to like worry to measure this super obscure format. If you are interested in calculating variance and standard deviation, I did throw a worksheet up on the AP Psychology student Facebook page. Again, you don't have to know how to do it, but sometimes it just helps to see where the numbers come from to really understand and to really get it. So it's there if you want it, but if you feel overwhelmed by it, don't worry about it. So for variance, we're actually measuring how much each score varies from the mean in a data set. And so you calculate by taking the standard deviation, or you calculate the mean, you square the differences, you divide the sum, and that gives you the number. So you really need to know is that variance is how far each number in the set is from the mean, or varies from the mean. And then from variance, we can calculate our next number, and you do need to know standard deviation. Again, not the full calculation, but you need to know what it is. It's pretty important. Standard deviation tells us how much each score also varies from the mean, and it's the square root of variance. That is the key. That might be a question on an AP test. So standard deviation is the square root of variance. So if there was a question on the AP test, I'm going to throw this at you. If variance equals 100, what is the standard deviation of the data? There's not too many people in here, but someone want to take a shot at that. If variance is 100, what is the standard deviation of the given data? And I'll leave that for a second and actually flip back. So remember, standard deviation is the square root of variance. So in that question, oh, my screen is frozen. There we go. In that question, yep, so it is the square root of 100. So that would be 10. So that's really all you have to be able to tell someone on the AP test. They might tell you what the number of variance is, and then you just have to say, oh, I know that that is the square root. So you take the square root, and it gives you 10 as your answer. It could go the opposite way too. It could give you standard deviation is 5, and then ask you what's the variance, and then so you would just square it. So 5 squared is 25 would be the variance. We like to see small numbers here because that means then that our data is closer to the mean, and then we know that the mean is a good representation. So this kind of links back to what we talked about with central tendency. If our standard deviation is a small number, that means most of the scores then are situated around the mean, which means that the average is a good statistical measure of the group. All right. The other thing with descriptive statistics that you have to know is this normal curve. And there is just some basic kind of memorization that you're going to have to do here. So in our data, a lot of times it forms what we would call a normal curve. Does anyone want to just throw some ideas in the chat about what forms a normal curve? What are some like data sets that would always form or typically form a normal curve? And I'll keep talking if you guys have some ideas. And so the mean on a normal curve is this the middle bar that's at the peak of the curve. And Rosemary is correct. IQ always forms a normal curve. So we'll use that as our example. If IQ is 100 for the mean, that goes in the middle there. And so that means 50% of the population is going to fall about under that, and 50% is going to fall above. And what you need to memorize here are the percentages. So that 34.13 on either side of the mean, those are standard deviations. So that -1, where it says next to the mean test score, that -1 is one deviation from the mean. And that +1 is also one standard deviation from the mean. So if we say that our mean is 100 And let's go back to the last question that we did. Standard deviation was 10. That means one standard deviation from the mean is going to be 90 to 100, and then 100 to 110. We go both sides of the mean, if that makes sense. And then if we're moving two standard deviations out past that where it says 13%, we would take another 10. So then we would have 80 to 100, that's two standard deviations, and 100 to 120. So that those are the percentages of people that would fall within that percentage range. So sometimes on the test, I've seen the question, how many people fall within one standard deviation of the mean? Well, there's a 34% below and 34% above, so you'd need to know about 68% of the population falls within one standard deviation of the mean. I've also seen them ask two standard deviations, which is about 96%. So I would honestly just get one of these graphs. You can just literally Google normal curve, and I would just mark it up at home. I would write down, maybe take like IQ or some other common factor and just label it out what that means, minus one standard deviation, plus one standard deviation, what that kind of means for like realistically with numbers, what that represents. And I really don't have, there's not a cute really way to remember that. You just kind of have to memorize 68 and 96% for those numbers. And then the more you just look at this graph and familiarize yourself with it, the less intimidating, I guess, it seems. I wouldn't worry about percentile ranks a whole lot. I don't think that that is something that would pop up on the AP test. It's mostly just the standard deviation piece and understanding what that means on the curve. Okay? Any questions about descriptive statistics? Otherwise, we're going to talk about inferential for a little bit and then do a practice FRQ. Give you a second. Well, if you have a question, throw it in the question box. Otherwise, we're going to move on and talk a little bit about inferential statistics. So for inferential statistics, we basically are just trying to consider, is our data reliable or not? Because if my data is not reliable, then I can't make some broad statement about humans or about the population as a whole. So how do we know if our statistics can be inferred like that? There's three keys that we look for, and you should know these. One is that representative samples are going to be better than biased samples. If you remember, we talked last week, and if we have a population, to make sure that that population is representative, we have to pull randomly from the population. So I can't do, let's use this example. I have an example listed of comparing intelligence scores of breastfed to bottle-fed babies. If I'm trying to make a generalization about breastfed versus bottle-fed babies in the United States, I can't go into one hospital in Madison, Wisconsin, and find out who's breastfeeding and who's bottle feeding and then compare that data. That does not give me any sort of an accurate representation. It might not be representative. Madison, Wisconsin is maybe not as diverse of a city as Chicago. The income level is probably quite different. So that sample that I'm taking, if it's just from one city, isn't going to be representative of the country as a whole. So that would be a biased sample. So we always want to make sure our population is representative of the entire population we're studying. Less variability in our observations mean that it's more reliable. So if my data points are everywhere and my bottle-fed scores are all over the place and my breastfed scores are all over the place, then I'm probably going to look at my data and say, oh, I cannot rely on this. It's not reliable. It's too variable, so I can't make these generalizations about it. And then the third thing is that more cases are better than fewer. So again, I can't study 10 women who breastfeed and 10 women who bottle feed babies and say, oh, yep, this is true to the whole population, because those numbers are just too small. There's too much room for error there because there's so many differences in humans already that those 10 aren't going to give me a good picture. So to use inferential statistics, we need more data points really to help us out and to help us make those decisions. So if we've determined that we think our data is good and we want to use it, the next step is to kind of think about if it's statistically significant. And this is another kind of big term that they throw at you a lot on the AP test. But basically in psychology, because like I mentioned, humans are so different and we have so many different ranges of emotions and intelligence and just genetics that it's really hard to have ever 100% of something in psychology because there's just always someone who's a little bit different. But we can speak in general terms. And so instead of having 100%, we try to go by 95%. So basically in psychology, 95% is our proof that something is true. And so that's what we would call statistical significance. It's represented by a lowercase p. So if you ever see that like p equals something, you know that it's referencing statistical significance. And then p stands for how likely the results were due to chance. So if p equals 8, that means there was an 85% chance my data was just random, basically. And so it's not good data. We want a lower number there. P has to equal less than or equal to 5% for us to feel confident in stating that our results are significant. So that's the cutoff. It's just a number you have to know. It's P equals less than, P is less than or equal to 5%. If that is true, then we can say that our results have significance and that our data has some sort of meaning. If that number is bigger than 5, then we're starting to think, oh gosh, there could be some other factors here that are messing with our data. We maybe can't really rely on that data. Let me see here. I think that is really all of the newish stuff that I have for you guys. Is there anything about that, the statistics, that is kind of still stuck and bothering you? I know sometimes this is an easier unit for kids just because you have some background with the research and with the labs and with the stats and the math kind of aspect of it. So sometimes that makes it a little bit easier. If we don't have any specific questions, I'm going to move on and then we're going to work on an FRQ prompt. So if you remember, I think 2 times ago, oh, yep, Rosemary, 1 second. I will go back to that slide for you. The biggest thing that you have to take away from this slide, if you're copying it down, is really that the P equals P is less than or equal to 5%. And then understanding that P references this idea of things being statistically significant. Do our results matter? Can we trust them? Can we continue with that research? Let me know when you're good, Rosemary, so I'll flip back over to the Chug Sodas FRQ. All right, excellent. So if you remember, we talked about this a little bit, and I'm going to reinforce it every time because I think just being able to write the FRQ isn't enough. I think following this criteria is really important, and so I really reinforce this with you guys. So remember to be concise in your FRQ. You should not be writing like pages for each term. You should be writing a paragraph for each individual term that's listed. Make sure you're checking your handwriting. I know that like when you're feeling cramped for time, that's hard. But if I can't read your FRQ, then you're not going to score points for it on the AP test. So make sure you practice that now. Underline, you should always underline the term just because it draws attention to it. You know, these people are sitting in a room grading papers for like 10 hours a day, and so they can make mistakes. They're human. So the more things that we can do to help them not make mistakes, the better off we're helping ourselves. And then you're getting rid of extra stuff, meaning we don't write a conclusion or an intro. We just get right into the meat of the response. Make sure we space out our writing, so we leave a space between paragraphs. You should respond to the prompt in the order it was given. You should define every term and apply every term and use synonyms when appropriate. So my prompt that I came up with, and this is actually a pretty common prompt in research methods, because Usually what they'll have you do is either design an experiment or critique some sort of experiment. And so this time I went with the design and experiment route. So this is pretty common. You might see something like this if you haven't taken your research methods test yet. And it also often pops up something similar on the AP test. It says to design an experiment that tests the hypothesis cooperative learning is more effective in raising test scores than direct teacher instruction. Use the following terms in your response. So then it lists independent and dependent variables, random sampling and assignment, ethical guidelines, and an interpretation of statistically significant. So this one is a little bit different because you have to first set up some background. So typically you would just start with independent and dependent variables, but it's asking you to do something else. You have to set up the experiment because the rest of your responses depend on what you write in that experiment. So if you don't write about the experiment, you're not going to score any points because there's nothing to reference what you're talking about. So you just have to give, it can be really basic. So what I wrote is, to test this hypothesis, we could design an experiment where one group of Ms. Ravello's students are given instruction directly via the teacher and the other use cooperative learning. After 2 weeks, we could measure their test scores and see how they vary based on instruction. So I have to now use my experiment that I came up with in all of the rest of my responses. So you're going to be using that as we go. An independent variable, then, you start with the definition, is the factor that is manipulated or changed in an experiment. The dependent variable is what is being measured. Those are just straightforward definitions. You don't have to get fancy there. You just show me that you know what the term means. Now, how do I apply that to the experiment? That's the key here. And so in the above experiment, the independent variable is the type of instruction because that's what some get and some don't. And then the dependent variable is the subsequent test scores. And that's really all you have to write there to get that point. You've identified, you know what the terms mean, and then you've identified in the example what those terms are. So it's pretty straightforward for that one. The second term could be a little bit trickier. And so it's asking us to define random sample and random assignment. Again, we're just basic definition. We would have left a space here between our paragraphs and then just start with a random sample occurs when each member of the population has a chance at being selected. So if the population is Miss Ravello's psychology class, you need to now tell me how you're going to take a random sample from that class because that's applying it to the scenario. So the easiest thing to do is put everyone's name in a hat and draw 20 names because everyone's name has a chance of being put into the sample. Random assignment refers to the fact that members of the sample all have an equal chance of being in either group A or group B. And so you could literally just say again, for this experiment, we're going to put those 20 names back in the hat and draw 10 for group A and 10 for group B. And that's how we'll do it. So again, you need to stick with whatever you wrote in the original experiment because that's what they're going to look at for comparing whether or not you're talking about the term correctly. Ethical guidelines we haven't talked a lot about, but it is in the research methods unit, so hopefully your teacher went over them. But defining ethical guidelines, you would just list that there are rules in psychology that should be followed during an experiment. And then specifically, you'd probably want to list what they are. And so the big ones that you need to know for AP Psych is that we should do no harm. We need to debrief or talk about the experiment when it's over. People have to give informed consent, meaning I can't force you to participate in an experiment. And then lastly, it needs to be confidential. I shouldn't be like sharing your test score saying, oh, look at Susie. She did so much worse on this test than Jimmy did. And then that is not nice and you shouldn't do that. That's a breaking in confidentiality. So I've defined ethical guidelines. And then in this experiment, I would talk about maybe one guideline that isn't being followed. So one concern of this experiment might be informed consent. If Ms. Ravello forces her students to participate, then she would be breaking an ethical guideline. To avoid this, she should have all students sign participation agreements beforehand. Rosemary is asking if we wouldn't have to define each ethical guideline. No. unless it lists a specific one, like debriefing or confidentiality, you could probably just pick one that you feel the most comfortable or the most confident talking about and apply it in that scenario. They're not going to make you write about 4 different ethical guidelines in that one little FRQ spot. So typically you can just pick the one that maybe seems the most obvious. Sometimes there'll be one that's really obvious. Otherwise, just pick whatever you feel best with. That would be the way to go. And then the last one, sometimes kids struggle with this because it says an interpretation of what statistically significant results would mean. And so they're like, oh, that's not a vocab word. But you can still pick out the vocab word here and define it. So clearly it's referencing statistical significance. And so that's how I would start, by defining statistical significance. Statistical significance refers to whether or not a result would have occurred due to chance. Sometimes too, if you're uncertain and you're just going to try and define a term, you're also not going to get docked for writing more information. They might not grade it and they might not score it, but if you're uncertain and you want to try and approach it 2 different ways, you could write, as long as you're not contradicting yourself, you can write more information. So it doesn't hurt to do it. You just might run low on time, but it doesn't hurt to try. It's not going to cost you any points in the long run. So we've talked about what statistical significance is. And then basically I have to make up some statistical significance in my experiment because that result wasn't given. So in this particular experiment, let's pretend that statistical significance is 3.1%. Now you need to talk about what that means. You have to show you understand what statistical significance is. That means to us as experimenters that we can determine that our results are not due to chance, and therefore the teaching style of cooperative learning versus direct instruction has an impact on student scores. For us to feel confident in our data, it would be wise for us to do this experiment many times over with a larger sample size. So that last sentence was probably a little bit of an add-on. It wouldn't maybe be necessary, but it kind of rounds out and shows your understanding of what we want to do with data and how it helps us determine whether it's significant and whether we can infer based on that to the rest of the population. So that's just a broad overview of the FRQ. If you guys have more FRQ related questions or want to see more examples like this, I can post some in the Facebook group. Otherwise, like I said, we will be doing these every other week. So next week, we're going to focus again on multiple choice questions, and then we'll go back to FRQ and we'll kind of alternate back and forth because those are the 2 big skills you really need to develop for the AP test. Any other questions before we kind of close out for tonight? Give you guys a second. I think it's like Rosemary's good. I feel like everyone else, it's kind of quiet in the chat tonight. But if you are enjoying 5 make sure you follow Crowdcast because it'll always let you know the next time that we're on. Follow us on YouTube. We're posting videos. I'm going to be making a video that shows you all of the steps to calculate standard deviation. If you're interested, if you're really into stats, that's your thing. Join the Facebook page, register for online reviews, and otherwise, that is all I have for you guys tonight. Rosemary, thank you so much for participating. I really appreciate it. Yeah, otherwise, good luck on your test tomorrow. I'll be in the Facebook page if you have any questions. Have a good night. Bye.